Hi, my name is Elizabeth Lundgren. I'm going to present my final project, Generating Music with Google Magenta, which is my project for CSCI E89 Deep Learning offered by Harvard University Extension School in spring 2019. So what I did for this project was generate 12-bar blues melodies with Google Magenta Improv RNN model. And I wanted to determine if the Improv RNN model in Google Magenta does a good job generating blues melodies given an underlying C 12-bar blues chord progression. So I did this by training it first with the attention configuration on blues genre files downloaded from musescore.com. I then predicted melodies using the trained models, giving it 12-bar blues chord progression and two different initial melodies. First, just the one note C, and second, a 1-bar melody that incorporates a C blues scale. I then predicted melodies using the same underlying conditions using a pre-trained model that comes in Magenta. So a little bit of background. Magenta is a Python API that came out of Google Brain. Its intention is to make music and art using neural networks. It's built on TensorFlow, and it's freely available on GitHub at the TensorFlow site. The Improv RNN model is just one of many within Magenta, and the Improv RNN model generates melodies given two user-defined inputs at runtime. First, an initial sequence of notes, and second, an underlying chord progression that it's going to improvise on top of. The Improv RNN model features a long short-term memory neural network, and I'm going to use the attention configuration so that I can optimize usage of past sequences and hopefully generate better music. For this project, I used Mac OS, my laptop. I did not use the GPU, I used the built-in Intel Core i7. I used the most recent version of Magenta that's available on GitHub. And even though I used the most recent version of Magenta, I found that it actually requires Python 2.7. To listen to the generated music, I use GarageBand on my Mac. So I'm going to go over the steps that I did, and the intention of this is for other people to be able to go ahead and do the same thing I did and hopefully take it a little bit further or play with it, do your own thing. So first I'm going to go through downloading and installing Google Magenta, specifically the Improv RNN API. Next I'm going to go through finding and downloading data and then pre-processing that data so that you can feed it to train the Improv RNN model. Next, we're going to configure and train the model. And then, once we have our trained model, we can generate music using the 12-bar blues chord progression and some initial conditions. I'm also going to download the pre-trained model that's available on Google Magenta and generate music using that. I'm then going to compare the two results, the trained model and the pre-trained model, and also the results of using different initial conditions. So I'm going to use the same 12-bar blues chord progression for all of my instances, but for each model, trained and pre-trained, I'm going to generate music with an initial condition of a single note and also an initial condition of a longer melody. So let's get started. To download and install Google Magenta, you can follow documentation that's freely available on the internet at the Magenta site. If you have Mac OS or Ubuntu and you do not plan on using a GPU, you can actually use curl at your command line to install a shell script that, or I should say download a shell script that you can use to set up Magenta environment in Python. So here I give the instructions using curl. Once you download the shell script, you can run the shell script and it will give you, it will set up a virtual environment for you. Now this assumes you're using Anaconda, which I am. If you're not using Anaconda, you actually have to look more closely at the Magenta documents because you have to manually install it and it's a little bit more involved. Okay, so once you have your Magenta environment, you're actually all set to do stuff with the model. Magenta uses Python, it's built on TensorFlow, but you don't actually have to do anything with Python to run it. That includes pre-processing the data, that includes training a model, and that includes generating music. Instead, Magenta allows you to use shell commands, which you can use at your command prompt on your computer. So for this project, I still wanted to use Jupyter Notebook just because I really like how everything is contained and the output has a place where it can be saved. So I used the bash magic commands in Jupyter Notebook in order to do this. And I'm actually going to leave my slides for a little bit so I can show you my Jupyter Notebook. And I think it would be useful if we went through it to see what I did. Okay, so the first step is, really the second step is to pre-process your data. So the first step is really get your data. I went to musescore.com, which is a site recommended by Magenta to get files in music XML format. Music XML format is the only format that you can use with the pre-processing commands in Magenta to pre-process data for Improv RNN. And you can think of music XML as like an XML file, except it's for music. So there's actually sites where you can display the score of the contents, and it includes information like chords and melodies. So once you get your music XML data, as I said, got it from Music Score. I searched for blues and I downloaded about 100 files and I went through each one to see which one looked like an actual blues melody. I ended up with about 50. So then you're ready to pre-process. So this first Jupyter cell I have here does that. The main function is convert dir to note sequences. So what this is going to do is it's going to take my directory that contains all of my music XML files. It's going to recursively go through each file, and it's going to convert each one to note sequences, which it's going to store in this single output file, notesequences.tf.record. Okay, so when I did this, I got all kinds of output from Magenta, and there's a whole bunch of lines that say info. That means that my file was successfully converted. I also had a whole bunch of lines that said warning, and this means that one of my files was not compatible and it was skipped. So here's an example where my file was skipped because it says unpitched notes are not supported. So unfortunately, about a third of my data was thrown out during this step, which was a little bit discouraging, but I still had data, so I went forward anyway. So the next step is the second of two pre-processing steps that you have to do to get the data into a format that Magenta will be able to use. So this one is function improv RNN create dataset, and I pass it the TF record file I just created. I also pass in an evaluation ratio, which is the ratio of test data to training data that it will produce. And I also pass it the attention improv configuration, because as I said earlier, there's several configurations and I'm using the attention for my LSTM configuration. So when I run this, unfortunately, a whole bunch more data gets thrown out. However, it's rather cryptic in what it says. So for example, here, extractor training polyphonic tracks discarded 77. I don't actually know what that means. All I know is I ended up with 12 outputs, processed 33 inputs total, only 12 outputs. It looks like it threw away most of my data. Oh well, I will keep going. So next, I want to configure and train the model. Here, I'm going to go back to slide view because it's easy to see the code here. You don't actually need to look at it in the Jupyter Notebook. So to train the data, I use improv RNN train. I set some of the architecture for my LSTM. I'm going to use a batch size of 64. 2 layers, each with 64 neurons and 500 training steps. When I train, it takes about 20 minutes. I plateau with about 85% training accuracy, which isn't that great. I also was not able to test my test data because the evaluation function is supposed to work with this, and for some reason it was giving me syntax errors, which I couldn't figure out. So I just skipped that and just moved on with generating music. So I generated 10 tunes for each of 2 initial conditions, 12-bar C blues, with an initial note of C, and also the 12-bar C blues with initial 1-bar melody incorporating the blues scale. And here you can see there's a function improv RNN generate. You pass a primer melody and you pass the backing chords. I also did this with a pre-trained model, so you can download this chord pitches improv.mag file from download.magenta.tensorflow.org and use the improv RNN generate function again, using the same chord progression and the same initial files. So let's see what I got. Okay, that was really bad. So that was my trained model, predicated with initial note of C, is very dissonant. How about my trained model using the initial melody with a blues scale? That sounded pretty good. If we kept listening to it, which we don't have time for, you'll hear that there's actually dissonance that come in, but it's pretty good. How about the pre-trained model, starting with C? So that sounds cool, but it really doesn't sound like blues. It sounds more like pop. How about if I give it the blues melody? All right, that sounded pretty cool. It got a little bit weird towards the end. I can't play out these whole things, but yeah, it wasn't bad. In the end, it did sound more like pop. So overall, if I use my single initial note C, it's not that great. It's dissonant with my trained model. It's a pop song, not a blues with my pre-trained model. The best results are actually with my initial blues scale melody using the pre-trained model, and that's most consistently good music generated. So, in summary, Magenta is really easy to use. You don't actually have to know Python or LSTM concepts, so that makes it really accessible, and you can download it from the internet. It comes with this pre-trained model, which means you don't have to actually go search for data, and it's really fast to generate results. You get music generated within seconds. The problem is, though, that if you don't need to know Python or long short-term memory concepts, well, you don't actually learn much from it. The TensorFlow code is abstracted away. You don't actually see any Python. Yeah, it's just not a really good teaching tool, I think, for neural networks. It's also unclear what the training data requirements are, so it was really discouraging that most of my data was thrown away. And the music XML format itself was pretty hard to use because I couldn't open it on my computer. I had to go to the site to actually view it. And also, the Magenta just didn't really do that great. Like, we heard a pretty okay one just now, but most of them actually weren't that great. They were pretty dissonant. I think that's because my training data had a lot of like non-standard musical modes, which is common in jazz, really. So there's a lot of like strange intervals going on. So future work, it would be better to understand the training data requirements, like figure out why most of my data was thrown away and figure out how to make a training data set where that will not happen. That might be finding better files on the internet, or it might be even creating training data files from scratch, which you can do. It's a little difficult with the music XML format, but that musescore.com does give you the capability of doing that. It does cost money, though. I signed up for a free 30-day trial, which I'm going to cancel. So here are my references. You can check out the Music Magenta documentation at GitHub. Here are all the files I downloaded from Music XML, in Music XML from musescore.com. And yeah, that's it. Thank you.